yesterday we worked out a bunch of stuff on angles, and like you guys said, kind of helpful, I thought, and you thought too. So we're going to do the same thing here. We're trying to find the sine of negative square root of 3 over 2. Okay, so we got to figure out what quadrant this is in. Normally, we would draw the angle first, but on this one, we're trying to find the angle. We're trying to find theta. So we're going to figure out what quadrant is sine negative. So we should remember, all students take calculus, right? So where is the sine negative? Yep, third and the fourth quadrant. Because first quadrant, they're all positive. And in the second quadrant, sine's positive. And obviously, this sign here is negative. So now we're going to draw a triangle in the third and the fourth quadrants. Now, when you're drawing it, always the angle is up by the origin. And these are reference angles, really. Okay, so sine is what over what? Yeah, opposite over hypotenuse, because so that means the opposite is negative square root of 3. So opposite is negative square root of 3. And the hypotenuse is 2. Same thing over here, negative square root of 3, 2. What angle is the reference angle in order to make this kind of triangle? Which one's across from the square root of 3?
No, 60.
60. Now that doesn't mean that's the angle, but that means that's the reference angle. So for my first angle, it goes from here to here. How many degrees would that be? Or how can we find it? Yeah, it goes half the circle, which is 180 plus that 60 degrees more. So that's 240. So there's one of my answers. Now to get the other, it goes from here and then ends right there. How much is that purple one? Yeah, the whole circle would be 360, and then we have that little reference angle that's taken out. So if you did 360 minus 60, that tells us that angle is 300. So the sine of 240 and the sine of 300 are both negative square root of 3 over 2. And that's how you do those without a calculator. And that's finding the angle. Yesterday, we spent most of our time finding the sine, the cosine, the tangent. Okay, now grab you a calculator, because we're going to do how to do this with a calculator. Okay, so on the next page, it says solve each of the following trig equations, finding two values for theta. Notice it says from 0 to 360. Give your answers to the nearest thousandth of a degree. Show your work. So here's the problem with using a calculator. Our calculator is only going to give us, it would only give us one of these answers that we came up with on this last problem. It would only give us one of those. And it might even give us a negative angle. And we want our answers to be between 0 and 360. So we're going to have to figure out what the other angle is, and if they give us a negative angle, we're going to have to figure out what that is if it was a positive angle, a coterminal positive angle, which we're good at. We can do that. Okay, so first, this is the part you can definitely use a calculator for. To find theta, and you have this weird decimal, how can I figure out what theta is? If I can use a calculator.
Inverse.
Yeah, I do, yes. I do the inverse sign of both sides. Because inverse and regular sign cancel out, and you get theta equals the inverse sign of 0.735. And it said this was in degrees, so make sure that your calculator, and we're going to have to change it halfway through, but make sure your calculator right now is in degrees. And you just hit inverse sign of 0.735, and it says round it to the nearest thousandth, so 3 decimal places.
447.307.
Yep. And that's in degrees. So that's definitely between 0 and 360. So we're good. It's like here-ish. There's theta. But I need the other angle because I know there's two. So where else is the sign a positive? Yeah, all students take calculus. So sign is positive also in the second quadrant. So I gotta find this angle, but my reference angle is still gonna be the same as this one. So this reference angle here should be 47.307 because that would give us the exact same, if we found the sides and did opposite over hypotenuse. So how do I find this other part of that angle? That black angle.
Subtract it from 90.
Well, that would give us this angle.
Subtract it from 180.
Yeah, I want this whole angle from the standard position. So 180 minus 47.307. And that gives us what? Becca, what'd you get? 180 minus 47.307.
132.693.
Yep. So both of these are our answers.
I have a question.
Yes.
So, the first, okay, so if we put, at the very beginning, we put the sign of,
The inverse sign of blah, blah, yeah.
yeah, and then you got 47.07.
Mm-hmm.
Is that always going to be in the first quadrant?
No. You have to look at it. You just see what angle they give you. If it's between 0 and 90, I know it's in the first quadrant. If it gave me like,
Oh, okay,
yeah, so you can tell where it is. Yeah, I gotcha. Yeah, it's just based on being in standard position, how far it goes. Good question. Anything else yet? All right. Next one, cosine of theta equals negative 0.482. So what do?
You do the
Inverse.
cosine.
Yeah. Inverse cosine of negative 0.482. What does that one give us?
118.82.
Yeah, if we had 3 decimals, it would be 8.16, right?
Yeah.
It's always 3 decimals just because in AP you have to use 3 decimals, so might as well get into the habit now. All right. So what quadrant is that in? Second quadrant, okay. And where is cosine negative? Because this was a negative 0.482.
In the third quadrant.
Third quadrant and the second quadrant, which makes sense because that's what we just found. Because it's all students take calculus, so it's not in the first and it's not in the fourth.